One of the most common questions when people are configuring their FTIR spectrometer has to do with the detectors. I'm going to talk about two detectors that we work with, and those are the deuterated L-alanine triglycine sulfate, which is sometimes called a DTGS, or in other cases just a TGS. And the other detector is the MCT, or mercury cadmium telluride detector, which is, well, I'm going to describe what they are. The DTGS detector is a room temperature detector, meaning you don't need cryogens, you don't need chillers or coolers or anything like that. The MCT is a cryogenic detector, which means you either need liquid nitrogen or some kind of special cooling for it. The DTGS detector tends to be less expensive because it's just a heat detector. Basically, this detector is just detecting heat. It's like holding your hands up to a fire and you feel the warmth of the fire. That's what the DTGS senses. It feels the warmth. It feels the heat. Okay, the MCT, on the other hand, is a little more expensive. It's a more expensive detector. And it is a quantum detector, means it's detecting photons. It's actually seeing the light and detecting those. What happens with this is that the DTGS detector is slow. And you'll see that clearly demonstrated when we go over to the lab. Whereas the MCT can be very fast. The other key point here is sensitivity. If you consider an IR peak, so there's an IR peak. The DTGS detector, with its lower sensitivity, has a background that's about here. So what I see when I collect the data is a peak that looks like this. Whereas the MCT has a noise background down here and sees the entire peak, which means if the peak is really, really weak, like that, it may be that the MCT picks it up and the DTGS does not. So when would you choose one detector over the other? The DTGS is the most common. It's in almost every instrument. It comes standard on our Thermo Scientific Nicolay IS-50 FTIR spectrometer, along with most of the others. The MCT is an option that can be added to them. And the critical thing is, are you studying kinetics? Are you studying something that requires the instrument to respond quickly? In that case, the MCT may be for you. And also, if you're using a microscope, in the case of a microscope, you're looking at a little teeny tiny sample. And when you're looking at that little tiny sample, you need to get all of the light you can. The MCT is much more sensitive at picking up that light. So most microscopes, most FTIR microscopes, will use an MCT or an array of MCT type detectors. So that's basically the two kinds. You have the thermal detector detecting the heat. You have the quantum detector detecting the light. Slow, fast, inexpensive, a little more expensive. And now let's go in the lab and see how the two of them work.